This is the Unit 2 review, Part 2. Looking at question number 1. It says, find the number and the types of solutions for x squared plus 6x equals negative 9. So what we need to remember is first we want everything on one side and our equation set equal to 0. So I'm going to add 9 to both sides of the equation. So the 9's cancel out. On the right side, I get x squared plus 6x plus 9 equals 0. To do this, we use our discriminant, which is b squared minus 4ac. Okay, so from here, remember, if it is b squared minus 4ac is greater than 0, we have two real solutions. If it is equal to 0, we have one real solution. And if it is less than 0, we have one complex solution, which is also our non-real. So complex and non-real mean the same thing. I need to identify my A, B, and C. So my A equals 1. There's a 1 right here in front of that x squared. My B equals 6, and my C equals 9. So from here, I just plug in my values. So I have 6 squared minus 4 times 1 times 9. 6 squared is 36. Negative 4 times 1 is a negative 4. Negative 4 times 9 is a negative 36. 36 minus 36 is 0. So it says find the number and the types of solutions. So I have 1. There's the number, real solution, and that is the type. So there we go for number 1. Looking at number 2, it says write the function f of x squared in vertex form and identify its vertex. So notice I have it equals f of x. I don't really like that, so I'm going to change f of x to 0. Negative 2x squared minus 12x minus 22. Okay, in order to do this, remember I'm going to add over my c term. So I get 22 equals negative 2x squared minus 12x. This is where I added my spaces to keep everything balanced. So negative 12x plus space. There we go. Now from here, if I notice, I have a value in front of my x squared. So I need to factor that out. So in order to do that, I'm going to divide everything by negative 2. Okay, so I'm dividing these terms by negative 2. So I get negative 2 out front. That's my greatest common factor. I'm left with an x squared. Negative 12x divided by negative 2 gives me a positive 6x plus my space. I still don't know what that is. And then over here, I still have the 22 plus the space. So from here, I find my half term. Okay, I'm going to find half of 6. So half of 6 equals 3. And then I square it. So 3 squared equals 9. So 9 goes in this blank. But in order to go over to the second blank right here, I have to take that 9 and I have to multiply it by the negative 2. Because remember, I factored it out and I divided everything by negative 2 up here. So 9 times negative 2 is a negative 18. Okay. And then I have to do my little shortcut. So remember, I have my parentheses squared. I have my variable and my half term. Can't forget about my GCF. And then I have to add these two terms right here. So 22 plus a negative 18. So remember, that's a negative 18. When I do that, I get 4. So it equals 4. In order to get it into vertex form, everything has to be on one side. So I need to move this 4 to the other side. So that cancels out. I have it back to 0. Negative 2, x plus 2 squared minus 4. Now, originally it started with f of x. So I'm going to go ahead and change that 0 back to an f of x to get my full equation. So there is the vertex form. Now it says also to identify the vertex. So my vertex Remember, it's the opposite of what's on the inside, so I get a -2, and then whatever number's on the outside, -4. So that is my vertex. Number 3, on yours, it would be number 18. Sorry, my numbers are a little out of order. It says, find the zeros of h of x equals 4x squared minus x plus 5 by using the quadratic formula. Okay, so first I need to identify my a, which is 4, my b, which is -1, and my c, which is 5. Also, I don't have to worry about that h of x. Everything's on one side, so I'm good. I can just jump right into it. So I like to start by finding the discriminant first, b squared minus 4ac. So I plug and chug. So -1 squared minus 4 times 4 times 5. Be sure that when you put negative numbers and square them into our discriminant formula, that they're in parentheses. It does make a difference. Okay, so -1 squared is 1. -4 times 4 is a -16. -16 times 5 is a -80. Okay, from here, 1 minus 80 is a -79, which means I have 2 complex solutions, or non-real, meaning I will have imaginary numbers in my answer. So from here, I go to the quadratic formula. I get x equals -b plus or minus the square root b squared minus 4ac all over 2a. And I plug and chug. So I get x equals, I have a negative, I'm plugging in a -1 for b, plus or minus the square root of a -79, because we just found that right here, the b squared minus 4ac, all over 2 times 4. So now I just start simplifying. I get x equals negative times a -1 gives me a +1, plus or minus the square root of a -79. There's not a perfect square that goes into it, but there's a negative there, so it becomes an I, and it stays rad 79, all over 2 times 4, which is 8. So this is my answer. I may also see it as x equals 1 over 8, plus or minus the square root of 79 over 8i. That's just another way that it could be written. They are the same thing. It means the same thing. Okay, moving on to my next question. It says, find the zeros of f of x equals x squared plus 7x plus 9 by using the quadratic formula. Okay, remember zeros are the same things as roots, solutions, x-intercepts. They're all the same thing. So I'm going to do the same thing that I did on the previous problem. Okay, it's f of x, so everything's on one side. That makes it nice and easy for us. So I get a equals 1, b equals 7, c equals 9. My formula, b squared minus 4ac. I like to find the discriminant first so I know what kind of solutions I'm looking for. So I get 7 squared minus 4 times 1 times 9. 7 squared is 49. -4 times 1 is a -4. -4 times 9 is a -36. 49 minus 36 is 13, which means I have 2 real solutions. So I should not have any imaginary numbers in this. So I go to the quadratic formula from here. I like to write it out. It just helps me memorize it better. So -b plus or minus the square root b squared minus 4ac all over 2 times a. So here I go. I plug and chug. So I have negative. I'm plugging in 7 for b plus or minus. We already found what's under the radical. That's our discriminant, which was 13. All over 2 times 1. And I start simplifying. Let's see. A negative times 7 gives me a -7 plus or minus. We cannot simplify the square root of 13, so it stays like that. All over 2 times 1, which is 2. This is my answer. I have 2 solutions because I have a plus and I have a minus. Okay, looking at the next question, number 5. On yours, it would be question number 20. So it says, add the results in the form of a plus bi. So we have a negative 5 minus 2i plus 9 minus I. In this equation, we don't have to worry about distributing the positive because it doesn't change our sign. So I can drop the parentheses like that. And then I'm just going to combine like terms. So negative 5 combines with 9. Negative 5 plus 9 gives me a positive 4. And then negative 2i minus I gives me a negative 3i. That's all there is to simplifying. Now, if it were a negative, so if I were to change it as negative 5 minus 2i minus 9 minus I, I'd have to make sure I distribute this negative sign to everything after it. The original, or the first parenthesis stays the same, and then I get a negative 9 plus I, because I distributed that negative, and I still combine like terms like I did, but now I have negative 5 minus 9, which gives me a negative 14, and then I have a negative 2i plus I, which gives me a negative I, or a negative 1i. So that's just a little extra if you watch this video. Okay, from here it says solve the equation 5x squared plus 125 equals 0. There's a couple different ways you can solve this. I'm going to do it the way that I prefer for this one. You could use a quadratic formula. Again, quadratic formula works for everything. Okay, so how I'm going to solve this is, since it's set equal to 0, and I notice I'm missing that b term, it makes it a little easier for us. So again, we're missing that bx term, which kind of takes away from having to do the quadratic formula. I'm going to add the 125 to both sides, or subtract the 125 to both sides. So I get 5x squared equals negative 125. From here, I want to get that x squared by itself, so I divide both sides by 5. I get x squared equals negative 125 divided by 5 gives me 25 negative. And then now I have something that's squared right here, and I want to undo it, so that's where I take the square root. Remember, they're opposites, they're inverses. The radical cancels out the exponent. I'm left with x. Anytime I take the square root, I have plus or minus. Square root of 25 is 5, and it has a negative number under the radical, so I have an imaginary solution. So x equals plus or minus 5i. Okay, the next question says express 6 square root of negative 60 in terms of I. So first off, I'm going to rewrite this 6 times the square root of a negative 60. So from here, I like to split it up so I remember that I have 60 times a negative 1. That way I know I have an I because it says in terms of I. Now I need to go through my perfect squares. So 60 falls between 64, which is 8 squared, and 7 squared, which is 49. So 60 is somewhere in here. So I'm just going to go through the list to see if any of my perfect squares go into it. So 64 doesn't. If I take 60 divided by 49, that doesn't work. I go to 36. 60 divided by 36, it doesn't work either. 25 doesn't work. From 25, I go to 16. That doesn't work. 9. 60 divided by 9. Nope. Not today. And then let's say 4. Well, 60 goes into 4. So I'm going to break this down. So 4 is our winner. Winner, winner, chicken dinner. We get 4 times 15 times the square root of negative 1. So if I were to multiply 4, 15, and negative 1, I should get negative 60. So from here, I split it up into their own individual radicals, which is a square root symbol, in case you forgot. So the square root of 4, remember I'm multiplying the 6, so I have 6 times. The square root of 4 is 2. I can't simplify the square root of 15 anymore, so it stays in the radical, and the square root of negative 1 is I. So 6 times 2, so now I got to multiply these two, is 12, I, and then rad 15. So that is simplified into terms of I. Looking at the next question, it says solve 81 x squared equals 1. Well, look, it's already said equal to 1. I just need to divide by 81. Okay, again, I'm missing that b term, so I can kind of do it like the previous question with the 5x squared and then 125. So I divide by 81, I get x squared equals, leave it as a fraction, 1 over 81. I have this squared, so I'm going to do the opposite and take the square root of both sides. So that cancels out. Remember, I took the square root, so it's plus or minus. What we can do with fractions is, remember, we can do the square root of 1 over the square root of 81. Well, the square root of 1 is 1. The square root of 81 is 9, so I get plus or minus the square root of 9. And that's it. Okay, makes it a little simpler on us. The next question is 24 on yours, I believe. Sorry, my numbers again are messed up. It says, what expression is equivalent to 3 minus 2i squared? Well, remember, since the exponent is 2, that means I have 2 of them. So I have 3 minus 2i times 3 minus 2i. For those of you that like FOIL, this is where you do first times first, outer times outer, inner, and last. I'm not a FOIL fan. I prefer the box method. Okay, so I'm going to write out my box. I have 3 minus 2i, 3 minus 2i. 3 times 3 is 9. 3 times negative 2 is negative 6i. Negative 2i times 3 and negative 6i again. Negative 2i times negative 2i is a positive 4i squared. Remember, I squared, it equals negative 1, which turns that into a negative 4. Okay, from here I can combine my like terms. Okay, so my 9 and my negative 4, that combines for 5. My negative 6i and my negative 6i give me a negative 12i. And there we go. That was on our last test too. Don't know if you noticed that. Okay, next it says solve the equation x squared equals 55 minus 6x by completing the square. On the test, if you do not like to complete the square, guess what? You can factor. You can use the quadratic formula. In the study guide that I worked out, I guess I didn't read the directions. I've been hanging around y'all too long. I actually factored it instead of completing the square. But in the video, I'll complete the square because that's what the directions say. So when completing the square, remember, I want my x term to be positive because if it's not positive, it adds more work to me. So I'm going to keep that positive, but I'm going to move over that 6x because I want my a and my b on the same side and my c on the opposite side. So I get x squared plus 6x equals 55. Now I add in my spaces, x squared plus 6x plus space equals 55 plus space. I take my half term. What is 6 divided by 2? It's 3. Would have never guessed. Then I square it. So 3 squared equals 9. So I add a 9 here, add a 9 here. Then I go to my handy dandy shortcut where I put my variable, my half term, and then I add these two terms. So 55 plus 9 gives me 64. From here, I need to solve. Okay, I completed the square. Now I actually have to solve it. So I have something squared. Remember, to undo it, I take the square root. The radical cancels out the exponent. X plus 3. Square root of 64 is plus or minus 8. So now I have x plus 3 equals 8. I have x plus 3 equals negative 8. From here, I subtract 3, I get x equals 5. So there's one x value. I should get two solutions. Okay, and then I minus 3, negative 8 minus 3 gives me x equals a negative 11. There are my two solutions. So remember, you have to, once you take the square root, you have to have this plus or minus there so you can get two different answers. Okay, number 11, it says find the roots of the equation 24x minus 72 equals 2x squared. Well, roots, solution, zeros, x-intercepts are the same thing, but this one wants me to factor. So I'm going to go ahead and factor. In order to factor, I got to get everything to one side. So I'm going to move over this 24x. I like to keep my x squareds positive, and I'm going to add this 72. So So minus 24x plus 72. Get everything over to one side so those cancel out. I get that to be 0. I get 2x squared minus 24x plus 72. If I look, all my terms are divisible by 2, so I'm going to divide everything by 2. Okay, everything by 2, so I have 2 times x squared minus 12x plus 36. Now I factor. So x in a box. Remember, it's the first term times the last term. You ignore the GCF. So I get 36x squared, negative 12 on bottom. So what can I multiply to get a 36? Positive 36, but add to get a negative 12. Well, since the top of my x is positive, that means my signs have to be the same, and they both need to be whatever the bottom of the x is. So they're both going to be negative 6x and 6x. So I get x squared, my first term, my last term, and the two terms that I just found on the sides of the x. So x squared and negative 6, they have an x in common. X times x gives me x squared. X times a negative 6 gives me a negative 6x. And then x times negative 6 again gives me a negative 6x. So when I write this down, I have 0 equals my GCF, x minus 6 times x minus 6. Now I need to set each factor equal to 0, but if I notice, my factors are the exact same thing. I get two answers, but that's the same number. Now I do not have to set my GCF equal to 0 because it does not have a variable. If it had an x with it, then yes, I would have to set it equal to 0. So I do x minus 6 equals 0, and I solve for x, so I add 6, x equals a positive 6. So this would be where the vertex is just on the x-axis. So that's what this would look like. Next question, find the zeros of the functions. So again, this part of the test is going to be heavy on finding the zeros, the x-intercepts, the roots, everything you need to know. So here we go. Find the zeros. So we have, how do we want to do this? 17's not a very pretty number. I don't think that I will be able to factor this, so I'm not going to try to factor it. I'm just going to go straight to the quadratic formula because I know how to do it. Okay, so A equals 1, B equals 2, C equals 17. So B squared minus 4AC. So 2 squared minus 4 times 1 times 17. So 2 squared is 4. Negative 4 times 1 is a negative 4. Negative 4 times 17 is a negative 68. 4 minus 68, negative 64. Had to count on my fingers for that one. I get two complex solutions. Two complex solutions, awesome. Meaning, again, I should have i's in my answer. So I go to the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2 times a. So here we go. Let's plug and chug. We get negative. We're going to plug in 2 for b plus or minus the square root of a negative 64 all over 2 times 1. Well, negative times 2 is a negative 2. Plus or minus, 64 is perfect. Square root of 64 is 8, and it's negative, so I should have an 8i all over 2. If I notice, all my terms are divisible by 2, so I'm going to simplify them. So negative 2 divided by 2 is a negative 1. Plus or minus 8i divided by 2 is a 4i. And I do not have to write it over 1. If you do, that's okay, but you will not see that as an answer choice. Okay, looking at number 28 on my screen, it says 13. Again, I apologize for the numbers. It wants us to solve, same thing we've been doing. I'm going to stick with the quadratic formula because it always works. Always. Forever and ever and ever. Okay, but notice it's not set equal to 0, so I need to move the 45 to the other side. So those 45s cancel out. I get x squared minus 10x minus 25. Oh, no, minus 20. Can't count. Couldn't count on my fingers on that one. So I get that. Now I just label like I've been doing. A equals 1, B equals negative 10, C equals a negative 20. My formula, b squared minus 4ac. My b is negative 10, so I put it in parentheses and I square it. If it's not in parentheses, you will get a different answer. Minus 4 times 1 times a negative 20. Let's see. Negative 10 squared is 100. Negative 4 times 1 is negative 4. Negative 4 times negative 20 gives me a positive because it's two negatives and I get 80. So when I add that, I get 180, which means I should have two real solutions. Meaning we're going to have to end up simplifying a radical. So let's see. Now I plug it into my quadratic formula, so let me write that out so I know what it looks like. Sometimes I forget it, but I think I write it enough that I should be good. Here we go. We get x equals negative, I'm plugging in a negative 10 for b, plus or minus the square root of 180 all over 2 times 1. So a negative times a negative gives me that positive. It's my favorite. Now I need to simplify the square root of 180. Well, if we think about it, 36 goes into it, 36 and 5. Okay, so the square root of 36 is 6. I can't take the square root of 5, so it stays like that. All over 2 times 1 is 2. Again, I can simplify it, so why not? So 10 divided by 2 gives me 5. Plus or minus 6 divided by 2 is 3. The 5 under the radical stays under the radical because we can't touch it. It's protected by the house. And there's my answer. X equals 5 plus or minus 3 rad 5. So I have two answers there. 5 plus 3 rad 5 and 5 minus 3 rad 5. Okay, looking at my last two questions. Number 14 on yours, it would be 29. It says simplify. So I am dividing complex numbers. Remember, I do not want i's in the denominator. So I have to multiply by the conjugate. So the conjugate of the denominator, so I'm going to call it the conj, okay, would be negative 4 plus 3i. So I'm going to multiply the top by negative 4 plus 3i and the bottom by negative 4 plus 3i. This should get me to get the i's out of the denominator. So let's see, I'm going to do the numerators first. Top of the fraction first, I get negative 1 plus 4i. I get negative 4 minus 3i. Negative 1 times negative 4 is a positive 4. Negative 1 times a negative 3i is a positive 3i. 4i times a negative 4 gives me a negative 16i. 4i times a negative 3i gives me a negative 12i squared. Remember, I squared is a negative 1. So negative 12 times negative 1 gives me a positive 12. So now I combine my like terms. Okay, again, I combine my like terms. Checking to make sure I didn't do anything wrong. Oh, I did. I copied the question wrong. I'm sorry. I'm multiplying by the conjugate, which would be negative 4 plus 3i. I thought something looked off. So this would change that sign to a negative. And then this sign would be positive. So therefore, whenever I do this right here, I should get 12 times a negative 1, which turns it into a negative 12. I apologize for that mistake. So again, I just wrote down the wrong signs. So now I can combine my like terms. Okay, so when I combine 4 and negative 12, I get a negative 8. And negative 16i minus 3i, get a negative 19i. Awesome. Now I need to do the denominators. So again, I'm looking for just a number in the denominator, just a value. I do not want any i's in the denominator. So here you go. Make sure I didn't write it down wrong. Nope, we're good. So negative 4 times negative 4 is a positive 16. Negative 4 times 3i is a negative 12i. Negative 3i times a negative 4i is a positive 12i, which is good because we want those to cancel out. Negative 3i times a positive 3i is a negative 9i squared, which gives me a negative 9 times negative 1, which equals a positive 9. So 16 and 9, when I add those, that gives me 25. And then my i's cancel out, which is what I wanted. So I get negative 8 minus 19i divided by 25. Again, you could see it separated as negative 8 over 25 minus 19 over 25i. So it could be written either way. I accept either way. I think on the test it will be the way that's circled. Okay, question number 30. It says simplify 13i and then a really big exponent. So what we need to know for this equation and what we need to memorize is I to the first equals I squared equals negative 1, I cubed equals negative I to the fourth equals 1, and it repeats. So remember, if my decimal, when I type it in the calculator, I'm going to take this exponent and divide it by 4. If I get 0.25, the outcome will be I. If I get 0.5, it's negative 1, 0.75, and no decimal. Okay, so let's take this really big number, so 457,387. We're going to divide it by 4, and all I care about is the decimal. The numbers in front of the decimal don't make a difference to me. They don't mean anything to me. All I want to know is the decimal. So when I do this, my decimal is 0.75, okay, which means that that equals negative I. So what I'm going to do is I'm going to replace I to the 457,387th power with negative I. So I get 13 times negative I, and when I multiply them, I get a negative 13i. And that is my answer. This is all the questions for the test, for the review. It's finished. Good luck on your test tomorrow. Please make sure you study, and if you need to come in the morning, I'll be there at 6:30, helping anybody that needs assistance.